This is lesson 5-5, and it's expressions for surface area, and it's just a review before volume. This was one of the last things that we did before we left school, and I'm hoping that we'll get to go back, that we'll have time to actually finish Unit 5, but writing expressions is going to be a really important skill as you move into middle school. So before we attempt volume, I want to review surface area because I don't think that we got to do enough of it before we left school for it to be completely in your memory bank. So just a couple reminders for you here. The first, we're talking about terms. So what is a term? A term is the part of the expression that is added or subtracted, and it's separated by plus and minus signs. Oops, looks like I'm a little off the screen here. Terms are not separated by multiplication and division signs. If it has a multiplication or division sign between it, it's one term. So we practiced this quite a bit, and if you remember, you did a great job on this. So I'll just do a couple of examples with you. Get my paper behind here. So say we have the expression 4 plus 3 times 2. I'm looking for that plus or minus sign right here, and I can see that I have two terms now. 4, which stands alone, and then 3 times 2 is a term. This also has to do with PEMDAS, all right, which we'll talk about when we do the volume. Here's another example for you, a little bit longer. 2 times 4 plus 1 plus 6 times 3. Again, I'm looking for these plus or minus signs, and those are separating my terms. 2 times 4 is a term. Like those things, the math goes together. We have to do 2 and 4 together because PEMDAS says that those go together. 1 stands by itself, and 6 times 3. Here's one last example for you. 3x minus 4. Again, I have a minus sign here, and I have 2 terms. And this is a good example to remind you that no space equals multiply. So even if we see something up against a set of parentheses, that means multiply too. So say I have 2 4 times 2. Following PEMDAS, I'm going to do in the parentheses first, 4 times 2, and then that's just multiplication with 2. Okay, so my notes are 3 pages today, but it's just because they include pictures, so I have to switch the page every time so that there's room for them. Okay, so here's a real-world example for you. Elise wants to put carpet down in a room. The figure shows the shape of the room. There's also an expression for the area of the room. How does the expression relate to the drawing? So here's my drawing right here. I have a room, it's 8 meters on the long side, and 4 here and 4 here for a total of 8. Total of 8 here, 4, 2, and this one doesn't have the label on it, but I would be able to tell that it's 2. And this one is 5 and 3. So total of 8 as well. I went ahead and labeled all of these for us because we're not practicing the skill of finding those side lengths. But remember that you could or might need to find some side lengths that aren't labeled using subtraction or addition, but you would have all of the numbers there that you would need to find them. So this is the expression that is given. 8 squared minus 2 times 3 minus 2 times 4 equals meters squared. So first thing I'm going to do is pull this out. This is not a variable. This isn't really a part of the expression. This is just the label for it. So this is the unit label. It applies to the entire expression. And is not a variable. It kind of looks like it could be a variable if we had m as a variable and that m was squared, but it's not. This is just, instead of having 8 meters squared minus 2 meters times 3 meters minus 2 meters times 4 meters, that would get really sloppy in there, and then we would have something even more complicated that looked like variables everywhere. So it's at the end here. All right, so how does this expression relate to this shape? So the first thing that I have is 8 squared. And we know that 8 squared is 8 times itself. 8 times 8. So that's representing this side length here. And then like I said to you guys, we have 4. And this length is 4 as well, because of right here. So this is 8, or I could go on this side, 5, and this portion is 3. So here's my 8 times 8. So of this entire shape right here, it's 64 meters squared. It's 8 times 8, and it's represented right here. This expression uses subtraction. So this 2 times 3, that's right here. And it's subtraction because I'm taking it away. Like this is a cutout in the room. It's not actually there. So I have to take my entire 8 times 8 and take away this 2.3. So that's why it's subtraction. There's dividing my terms, by the way. So this is the entire room. This is the missing part on the left. And now I have this piece as well right here that's not actually part of the room, but I included it in my initial number. I'll do this one in blue. This one is 2 times 4. So here's its term. And this is the missing part on the right. So this hasn't even been solved. All it did was ask me to relate the expression to the drawing and show which pieces were which. So this was one using subtraction. We did practice both of these. I'm gonna do the addition one, or a addition one. There's more than one option. So here's a second option. Say I wanted to divide my figure like this. There's other ways you could do it as well. Actually, this one's probably the best way. Since these are not even, it would be, well, you could do this one as well. Anyways, I'm just gonna do mine like this, into 3. Okay, so now I have 3 rectangles. This one, this large one, and one over here. So I'm not including these. I'm just going back to my initial shape of the actual room. I'm not going to subtract anything this time. This is going to all be addition. So first, I want to think about this rectangle right here. It's 5 by 2. So it is represented by 5 times 2. I could put parentheses around that if I wanted to. I also don't need to, because order of operations tells me that I would do that together, and that is one term. And then I'm going to add it to my purple rectangle, which is right here. I know that this total long length right here is 8. I have 5, that's labeled right here, and then 3, which is labeled here. 8 times 4. And then I have one more rectangle to add, and that's this one right here. This length is 4, and this length is 2. Right, so I have 2 different expressions that could represent the area of this. They don't need to be solved, they're just an expression, so they don't have an answer, although we would be able to solve this, and you are welcome to do that if you want to. But just a reminder on that we're looking at, how we're breaking those figures down or different ways of looking at them, and then what our terms are. I'm actually gonna highlight these as well. Okay, one more page. You might have to dig a little deep on this one, going back to thinking about nets. So remember that a net is our 2D figure right here. So here's our 3D figure, and this is a 2D figure. You have notes about this, and you can look it up online. I don't have time to go back and do an entire reminder lesson about it, but we did these like where we cut them out of our notebooks and then we folded them on the dotted lines and folded them up into the figure. So here's the figure, what it would look like if it were folded up. And then this is what it would look like open, is this net right here. So this kind of thing can help us with surface area. So there's 2 possible expressions for this one. Well, there's more than that. Get my other notebook here. But I'm just gonna do 2 with you. I have a net, which if I had this figure, one of the review homeworks that I gave you has solid figures like this. So you need to think about what its net looks like. I can't remember what unit that was, but I think that it was just unit 4. So you might need to look back into your notebooks for that. Right, so let's see. First I'm just gonna go through and write the math on this net. So my long lengths are 6. I have lengths of 3 and the little lengths of 2. So this one right here, and this one right here are equal, and they are 2 times 6. I have these little ones. And they're 2 times 3. And then my larger ones, they are 3 times 6. So if I only wanted to use addition, I could go through, I need to add all of these together. So if we're doing surface area, it's just the outside of this figure, and I would do the outside areas added together. So I could do 2 times 6 plus 2 times 6, there's my greens are done, plus 2 times 3 plus 2 times 3. Now my pinks are accounted for, plus 3 times 6 plus 3 times 6. So I've accounted for all of these rectangles. There's 1, 2, 3, 4, 5, 6. I have 1, 2, 3, 4, 5, 6. and I would do the math and add them together. Again, you don't need to have parentheses around them. Because of the order of operations and using PEMDAS, you could put parentheses, but even without them, I'm still going to do all of the multiplication first. So I would be doing 2 times 6 plus 2 times 6. I can go through and do that actually. 12 plus 12 plus 6 plus 6 plus 18 plus 18. And now I'm down to my addition, and I would just continue adding. 24, 12, 18. I actually cannot add those in my head. You guys are way better at adding things in your head than I am. I can definitely admit that. 8, 9, 10. All right, 54. There we go. Nope. What did I do wrong? Oh. There we go. Found my own error there. So I need to do 54 plus another 18. 8, 9, 10, 11, 12. For 72 total. And these are inches, and this is surface area, so it's just squared. Okay, so here's another expression for these. You can do it as addition, or we have 2 of each of these, so in this case, these ones can be multiplied by 2. So another one that we could do is 2 times 2 times 6. Plus 2 times 2 times 3 plus 2 times 3 times 6. Okay, so this one I did use parentheses. I have no space here, which is telling me that I multiply. No space equals multiply. And using the order of operations, first I would go through and I would do parentheses. So I still have 2 here, and then 2 times 6 is 12. Plus 2, and in my parentheses I have 6. Plus 2, and in my parentheses I have 18. So I went through, but I did it with multiplication instead of addition, and then I just end up with the same thing. Now this is no space, so I multiply. 2 times 12 is 24, plus 2 times 6 is 12, plus 2 times 18 is 36, not 18. And then my last step is the same. 72 inches, because that's the label, squared, because it's just surface area. Okay, so you have more examples of these in your Unit 5 notes, but I think that this should be enough to get you through the homework. You can definitely do 5-5 from the usual homework that we do, and then I'm also including a sheet that has figures like this, and that might be a little bit more challenging because you're going to need to think about what the nets look like or what sides you have that you're not able to like physically see on there. But I think that that'll be a good challenge for some of you and some conceptual thinking and to keep your brain working during this time. And then on Friday we will apply these expressions to volume. But I didn't want to jump right into that because thought we needed a refresher. All right, have a great day.